The people from the Department of CSC, Sri Vishnu Engineering College for Women, Bhimavaram. So first, we welcome you to this faculty development program, ma'am. Ma'am, first of all, we would like to convey our thanks to you, ma'am. Despite of your busy schedule in this time, you joined with us to share your valuable insights. Before entering into the session, let me take the privilege to introduce you, ma'am. It is my great honor to introduce Dr. Anupriya Jain. Dr. Anupriya Jain is currently working as a professor in Faculty of Computer Applications, Manavarachna International Institute of Research and Studies, Faridabad. She has more than 21 years of experience of teaching undergraduate and postgraduate students. She has published more than 30 research papers in various reputed journals. Her research interests are in the areas of software engineering, data mining, and computer organization. She has also written a book on computer architecture for MCA students. She has edited 2 books in publishers of international repute. She has chaired various sessions in reputed conferences. She has conducted and organized many workshops on latest IT technologies. She has published 3 patents to her credit. She is currently guiding 2 research scholars in the area of data mining. Really, we are glad to have such a great person as a resource person to this faculty development program, ma'am. Ma'am, now I request you to enlighten our participants on the topic of machine learning and its applications.
So thank you so much for this brief introduction of mine. I am obliged to introduce me to the audience. And thanks Vishnu Engineering College for giving me this opportunity to share my ideas on machine learning and its application, especially to Kiran Sri sir, who has given me this opportunity to interact with you all. So pleasure is all mine. Thank you so much, sir, for the introduction. So let me share the screen. Is it visible?
No, ma'am, not yet. Yes, ma'am, it is visible, but it is in design mode.
Is it in design mode? I have.
Please share the presentation mode window, ma'am.
Yeah, I have done that. Let me share it again, sir.
Sure.
Now is it visible, sir?
No, ma'am, sorry. Yes, ma'am. Now it is in presentation.
Okay, thank you so much, sir. So, good evening, all. My topic today is Introduction to Machine Learning. I hope you are already enlightened about what is machine learning, but I want to give some insight so as to how we can redefine the way how do we look at machine learning. So first, let us discuss why do we learn. Are the slides moving, sir?
Yes, ma'am.
Okay.
Here in the why learn slide.
Yeah.
Yes,
So why machine learning? Why do we want our computer to learn? Because machine learning is a particular branch where we want a machine to behave like a human being. As we all know, a computer is a machine wherein we gives the input, it processes something and it gives you the output. But before the advent of machine learning, only we are giving the input, we are giving some set of processing capabilities, and we are getting a defined output. Now, with this advent of machine learning, now we are giving the input so as to a machine can think like a human being. Machine learning is programming computers to optimize a performance criterion using example data or past experience. Like whatever we want to have, like if we want to say, I want to design a payroll system. So that is not a machine learning system. Payroll system is like wherein all the input output processing, they are well defined. We are not giving any wisdom, any experience to the machine. Actually, whatever we are giving, that is a predefined set of instructions, and we are getting the predefined set of outputs. Machine learning require where human expertise does not exist. Like when we want to navigate on Mars. So we have very much little knowledge on what is all about Mars. What are the data sets that we do have. So by giving the inputs again and again, again and again, again and again, we are training our machine to learn about what is there when we navigate on Mars. Second example is humans are unable to explain their expertise. Like if we discuss about speech recognition, now how am I talking? It is different. My vocabulary is different. My tonal quality is different. My accent is different. My frequency of word is different. So I cannot specify each and everything to a computer how to recognize my voice. But by speaking again and again, again and again, the machine will learn on its own. At a particular point of time, that particular machine can identify with various data sets, with various tonal qualities, it can identify who am I, who identify between the voices. Third example is solution changes in time. If we discuss about routing on a computer network, internet, as you all know, it is a wide network. So we cannot predefine a fixed set of routing algorithms. With time, with dynamic things, the things change on time. So the solutions are changing in dynamic sense. Like, for example, if I am following a strategy for a particular thing, for a particular routing, maybe within seconds, I have to change routing strategy from A to B. So machine learning is doing on its own. It is learning, it is taking the efficiency, it is taking the optimization algorithms, and it is learning on its own. Next is solutions need to be adapted to a particular cases. For example, user biometrics. Again, it is a different science. My fingerprinting mechanism, my fingerprints are altogether different from anyone. So computer is identifying the fingerprints, and it can identify so that it can be assured that my system is secure, or we can use biometrics in my attendance system. It can be used in any of the technologies. Now, next is what we talk when we talk about learning, what we want to learn. Learning general models from a data of particular examples. Actually, the machine, we are giving certain inputs based on the predefined, some base should be there. So we have a general models from a data of particular examples. Now, the second emphasis on machine learning is we have data sets, we have multiple data sets, we have data repository, we have data warehouses, we have data marts, but we do not know how to process the data. Analysis of data is very expensive, and deriving the data sets from that particular, deriving the analysis from the data is very scarce, and it needs engineering. So there the machine learning takes the role, and it is very important that we have to analyze the data, and what we are analyzing the data, we are feeding into the machine so that it takes decision on its own. For example, uh, suppose we are taking the customer transactions. Now here the behavior prediction, the sentiment analysis takes the role. For example, we have taken the association like people who bought Da Vinci Code also bought the 5 people you met in heaven. So that means we are establishing the correlation on the basis of behavior of the customer, on the basis of sentiments of the person. If we can say, if we can check while doing the online shopping, we are getting some alerts. You may also like this. You may also like that. What is that? Machine learning takes the role. Machine learning is doing the role. It is taking our interest. It is taking our data. It is processing the data, and it is giving you the some recommendations that you may also like this. You have taken this particular product. You can also add this into your cart. So that is where the machine learning plays the important role. Now, what we want to do, we want to build a model that is good and useful approximation to the data. So that means we have data, but analysis of data plays a very crucial part. For the sake of analysis, we are not doing it. We are taking the analysis, we are testing the data, we are validating the data, and if the analysis gives certain kind of accuracy, like if we are getting the accuracy of our analysis to 99.9%, we can say our next. Now, what is machine learning? Machine learning is a branch of artificial intelligence. By artificial intelligence, because we are inducing intelligence to our computer. Computer has all the capabilities, but we want our computer to behave, to take the decisions on its own. We are giving the data sets, we are testing the data, we are validating the data. Finally, we want the machine to be human free so that it takes the decision on its own. It makes the decision so that our system is robust. It uses computing based system to make sense out of data. Example is we are extracting the patterns, we are fitting data to functions, we are classifying data. Machine learning system can learn and improve with historical data, time and experience. We have certain data sets, we have the outputs. Now with historical data, we are feeding certain information so that with time and experience, our system is improving. Our system accuracy, our system prediction is getting improving day by day. It very important is it bridges the theoretical computer science and real noise data. Now, what do we understand with real noise data? We are getting the data from all the sources. Maybe the data is complete, maybe the data is incomplete, maybe the data is of different dimensions. Now, the main emphasis is to clear the noise. Noise is we want to normalize the data. We want to make the data in a single dimension so that we can take certain inputs out of the data. Right? Next. We want to optimize a performance criterion using example data or past experience. On the basis of experience, on the basis of human decisions, we are giving the input so that our machine is improving day by day. Here the role of statistics and computer science both is there for machine learning, because in statistics we are taking inferences from a sample, we are getting the inputs, we are making certain hypotheses, we are taking certain decisions. So correlation, all the mathematics and statistics play a major role while designing a machine learning system. At the same time, the computer science designs efficient algorithm to solve the optimization problem so that our computer or the machine is optimized. It represent and evaluate the model for inferences. On the basis of certain algorithm, now we have designed the model, now we have designed the machine, we are evaluating, we are checking whether our machine is behaving properly or not, like we wanted. Whatever is the objective, are the objective of our machine is achieved or not. Now, machine learning as a process, very important. What are the basic steps that while designing a machine learning, we have to follow. And we can say it is a machine learning life cycle. So first is defining of objective, very important. Because if the objectives, if the if the key features are not identified, if we are not sure of the key objectives, if we are not sure of the key objectives, so what we will design? So the most important factor of machine learning as a process is define the objective. It should be measurable, it should be quantifiable. We cannot say we want to design a machine. So we want to design a machine on which parameters, what we want to achieve. It should be quantified, it should be measurable. If we are saying our machine is behaving properly, so what is the accuracy? What is the precision percentage? So we have to take care while designing the objectives so that we can measure these objectives. Are we able to achieve that particular objectives or not? Next, use this stage to learn about the problem. Whatever we want to decide our machine to behave, are we able to achieve that in quantifiable and measurable forms? Next step which we do is data preparation. Again, it is very important. We are getting the data from different sources, different dimensions, different repositories. Now, first we want to normalize the data. Normalization of data means from multiple sources, we are integrating the data that conveys the same meaning. Maybe our unit is different, your unit is different. Now we must normalize to a single parameters so that it makes some sense. Second is we are transforming the data. Suppose my data is different, your data is different. Now we want to transform the data to a single scale. Next, we are identifying the missing values. If missing values are there, either we should remove the row or we should add certain values to that so that the machine which is behaving, it is giving you the accurate result. Last is we have to check about the outliers. Outliers is we are getting the over approximation and under approximation of data. If that is the case, we must remove that outliers. We must identify the outliers. We must identify the range so that we can identify what are the outliers and how to deal with that outliers. Next step is model building. Model building is first we want to split the data. Now data splitting means we are splitting the data into a testing data and a training data. Now what do you understand by testing data and training data? Training data is we are training the machine to behave as per the defined objectives, as in step 1. Testing data is whether we are giving the training data and we are getting the desired output is the testing data. So now data splitting can be in the ratio depending on your requirement. It can be in the ratio of 60-40. It can be in the ratio of 75-25, depending on what is the criteria for splitting. Next is we want to discuss about the features engineering. Very important. While designing the model, we have certain kind of data. We have n number of attributes, but now we want to identify what are the key parameters, what are the main features which we want to extract from this particular data. Next is we will estimate the performance of the model. Is the model behaving properly? Are we using the correct algorithms? Next, we are evaluating, and finally we are selecting the model. Selecting the model means we have multiple algorithms, multiple models. Now, out of the testing and training data, whichever is getting the best performance, we are taking that particular model. Next step is model evaluation. Now, after the model building, now finally we are evaluating the model on the basis of model accuracy. If it is working better than the naive approach or the previous system, if it is not working with the previous better than the previous system, it is of no use. We must change the model altogether. Next, they have to analyze the result that makes sense in the context of the problem. Let's say we are targeting the traffic congestion system. Now, the model is behaving fine, the accuracy is good, but it is not eradicating the congestion problem. So what is the use of designing that model? Now, if we are satisfied this model evaluation, then we will deploy the system, we will deploy the model, and again it is a cycle. Then again we will check whether the objectives are defined. We want to incorporate some data, incorporate some new model, and it goes like a cycle. Machine learning as a process, first is data preparation. Now, what is data preparation? It is needed for several reasons, and data is the king. If our data is not correct, the machine will not behave properly. So the most important part of machine learning is defining the objectives, what we want to achieve. Second is what analysis we are doing with the data. If the data is not processed properly, if the data is not transformed properly, the machine will not behave under any kind of good model we have. So some models have strict data requirements like scale of the data, what is the data point interval. Some characteristics of the data may impact dramatically on the model performance. Now, what is time on data preparation should not be underestimated. We should not compromise on the data. Very important. So first, we have to check the raw data. In raw data, what we have to check? We have to check for the missing values. We have to check for the error values. We have to check for different scales. We have to check for the dimensionality. We have to check for types problems and many others. Maybe it is an abstract kind of data. So we have to convert that data into a meaningful form. Next, after this raw data, we have to transform the data in the form of scaling, in the form of centering, in the form of skewness, outliers, missing values, errors. This has to be taken care while we are transforming the data. All the steps are clear, all the steps are done, then we are giving the data ready for the modeling phase. Now we have to test the data on the model which we are choosing. So machine learning as a process, next step comes is feature engineering. Now we have to identify the predictors, which is one of the most critical questions. Now, what is predictor? What kind of algorithms that we are using? What kind of strategies that we are using to define the model? Sometimes we need to add predictors. Now, we have two concepts, a wrapper and a filter. Anyone who can differentiate between a wrapper and a filter? The most important feature is predictors must be very less. If we are giving multiple objectives, multiple key features to the machine, it will not behave properly. We have to narrow down our objectives so that the machine behaves properly. So what is the difference between a wrapper and a filter? A filter is, we have certain kind of algorithms. We are choosing the multiple algorithms on the basis of performance, which algorithm will choose our machine, which algorithm is best for this kind of objectives to be achieved. Now wrapper is, on the basis of these filters, we have multiple algorithms on the filter. Suppose I have filtered 5 algorithms. Now 5 algorithms are tested on the data. Now wrapper will identify which algorithm is the best to suit this kind of considerations for designing a machine. So binning predictors is, on the wrapper and filter, we can use an embedded system, or we can choose a different set of algorithm where the machine behaves as per our requirement. So machine learning as a process. Next step is model building. Model building, we are discussing about the data splitting. Data splitting is, we are splitting the data into the training set and the testing data. So we are allocating the data to different tasks. Some data is used for training and some data is used for testing. That means we are checking the performance of the system. Next is, we are defining training, validation, and test set. Feature selection, what kind of feature we want to select from the machine. Finally, we are estimating the performance, we are visualizing our results, we are discovering interesting areas of the problem which was not identified in the conventional system or the previous system. Finally, statistics and performance measure is giving you the accuracy and the precision of that particular machine. After this, evaluation and model selection, the no free lunch theorem. This is very important. Every problem, it is not necessary that every problem should be suited to a particular set of algorithms. And there is not a favorite models. We need to explore much and much algorithms for every kind of system. This particular algorithm is best suited for this. Maybe out of the blue, which we are not thinking about the algorithm, that gives you the best result out of the our favorite algorithms. Next is supervised and unsupervised learning. Kiran sir, do we have some time or should I wind up?
HOD sir.
Kiran sir.
HOD sir.
Shall I continue with the presentation or should I take up? Am I audible?
Yes, ma'am, you are audible.
So due to certain time constraints, I suppose the next presentation is also scheduled. So shall I stop my presentation? Okay, so supervised and unsupervised learning. Supervised learning is where the objectives are defined. Unsupervised is we are not guided by any force. We are getting the information, we are interpreting the results, and we are taking the decisions. So unsupervised learning, the best example is clustering. They are not predefined and not known set of outcomes. We are checking the hidden patterns and we are getting the relation out of it. Supervised learning, we have some predefined outcomes. Suppose if we want to define certain classifiers, certain classes, we want to take a loan, we want to check whether they are eligible or not. So we will get two categories, yes, bad debt, good debt. So if there is certain conditions, then we can say we have the supervised learning. We are guided by certain outcomes which we want to decide. For every example in the data, there is always a predefined outcome. It models the relations between a set of descriptive features and a target. So there are two common problems, classification and regression. Again, supervised learning, we are defining the data on the basis of different classifiers, different classes. whether it belongs to a certain class or not. Regression is we are predicting the continuous values between the independent and the dependent set of variables. Now, how data mining plays a role in this machine learning? Data mining applications it is used in retail, where we are doing the market basket analysis. For example, where we are predicting the behavior, customer behavior prediction, and we are giving the information. Like in market basket analysis, if we want to go to a grocery store, we can see different similar kind of items are placed at the same corner, so that suppose if I am so that the customer find it easy and takes the maximum from that grocery store. So that is the kind of market basket analysis. Next is customer relationship management, very important. CRM plays a role where we are checking the what is the criteria, what is the basis. Suppose if we want to take a loan from a particular bank, so we are checking the CIBIL score, we are checking the credit history of a person, so that we can check whether this person can take, he is eligible for that particular loan or not. Next is for finance, we have credit scoring, we can detect the fraud. For manufacturing, we have optimization techniques. We can do certain kind of troubleshooting. If there is some certain problem in the area of medicine, we can do medical diagnosis, which is very important and very, very promising field for the data mining areas. In telecommunication, we have quality of service, we have optimization techniques. So the applications of this particular data mining or the machine learning lies in association, supervised learning. In supervised learning, we are discussing about classification, regression. In unsupervised learning, we are discussing about the clustering mechanisms. And in reinforcement learning is basically focusing on the game playing techniques. So learning association is basket analysis, as we have already discussed. We are checking the probability, the sense that somebody who buys a product X can also buy the product Y, where X and Y are products and services. Wherein, with the help of this, we can design the recommender system. Next, classification. In classification, we are using the credit scoring mechanism. We are differentiating between the low risk and the high risk customers from their income and the savings. If we can see with this particular diagram, we have two segments. It is a low risk segment, it is a high risk segment. Now, what is the basis of this variable? If income is greater than theta 1, and if savings is greater than theta 2, then low risk, or else it is high risk. So to conclude my session for machine learning, I can say machine learning is very promising area, and it needs lot of research, which is still very promising for our researchers, our research scholars, even the academicians, so that a machine behaves in a robust and error-free manner. So thank you so much. With this, I wind up the session.
Thank you, madam. It's a privilege to see you online in spite of your busy schedule that you said.
Thank you so much, sir. Pleasure is all mine. And sorry, sir, I could not make that particular presentation because due to shortage of time, I had to wind up in between. Some more slides to go.
It is concise, but it is very precise, madam. It's a very good presentation. That
Thank you so much, sir. Thank you so much.
Sunil sir, we can wind up, sir, please.
Yeah. Thank you so much, ma'am. Within a short period of time, you clearly explained about what is machine learning, why we machine learning, and some of the major points where we can use frequently in our regular life. Really, we, the people of Sri Vishnu Engineering College for Women, Bhimavaram, we thankful to you, ma'am, for joining with us to share your valuable insights. Thank you so much, ma'am.
Thank you so much, sir. Sir, shall I leave the meeting?
Yes, ma'am, please.
Thank you so much, sir. Thank you.
Thank you.
Thank you, ma'am.